Okay, today we're going to do experiment 9. Lab 9 is to determine heat of neutralization. And a strong base react with strong acid, reduce salt and water in the same time, release 56.2 kilojoule of energy. Like sodium hydroxide is a strong base, react with hydrochloric acid, which is a strong acid, produce sodium chloride, which is a table salt, also water. Release heat, we use enthalpy change, delta H. The value is 56.2 kilojoule per mole. This means whenever 1 mole sodium hydroxide react with 1 mole hydrochloric acid will release 56.2 kilojoule of heat. This negative sign means release heat. So these values applied to any strong acid, strong base reaction. Let's say if this is KOH, if this is HBr, then same amount of heat will be released. So we're going to test today if this amount is correct. So we will measure the experimental value. So what we're going to do is first we put some hydrochloric acid in a beaker or flask. It's 50 milliliter, 2 molar HCl, and we use a thermometer to measure the temperature. Measure the HCl's temperature at 0 minutes. This means at the beginning. Then every 1 minute, up to 4 minutes. Then in the same time, we put 50 milliliter. Actually, it was 51 milliliter NaOH. So let the NaOH a little bit excess. 51 milliliter concentration is the same, 2 molar NaOH in this beaker. And put a thermometer there and measure the temperature. And the measure temperature of this NaOH at 0.5, 1.5, 2.5, 3.5, and 4.5 minutes. This means alternatively first measure HCl's temperature, then there's the NaOH temperature, then back to HCl's temperature. So every minute measure HCl temperature, then every other minute, still every minute, but start at 0.5, then 1.5, 2.5. So every minute measure NaOH temperature. Then at 5 minutes, you mix NaOH with HCl and measure the temperature of the mixture. at 5.5, then 6, then every minute, up to 15 minutes. Then from this result, from the temperature you measured, include the initial acid minute of temperature and base minute temperature. Then the temperature of the mixture. We can find the initial temperature and the final temperature of the reaction mixture. And plot a figure looks like this. So this is time in minute. This is temperature Celsius degree. So at 5 minutes, we're mixing the acid and the base. So this line is a mixing line. So now record acid temperature every 1 minute start at 0. So acid maybe 20, and at 1 minute maybe still 20. At 2 minutes, 2 minute 2 maybe 20.5. At 3 minutes maybe back to 20, and at 4 minutes maybe 20.5 again. Then temperature of NaOH start at 0.5. Maybe this is 21, and this is 20.5, and 20.5, maybe 21 again, then 20. Let me use a red colored pen for base, so for you guys can read this clearly. 0.5, this is base temperature. Let's use different symbol. Let's use a circle. All right. Then we can find the initial temperature of acid and base. So draw a based line, based straight line. Let some point above the line, some point below the line. Clearly, this is the acid initial temperature. Let's say TA. A standard for acid. And this red colored dot for base. Draw a straight line. Let some point above line, some point below the line. Then this will be TB, standard for base. Then the initial temperature TI will be the average of temperature, initial temperature of acid and the initial temperature of base. So TA plus TB divided by 2. That's the initial temperature TI. At 5 minutes, we mix these two, then start to read temperatures at 5.5. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So at 5.5, temperature is this. I don't know what the actual temperature is. Might be this is 30, and whatever you rate. And the actual temperature rate During the experiment, I recorded in the data sheet. Just read the data sheet. Then at 6 minutes, the temperature may be this, right? And 7, drop a little bit. 8, drop a little bit again. 9, drop. 10, also drop some. 11, drop some. 12, drop some. 13, dropped again. 14, dropped again. And 15, dropped again. So you will find the temperature record like this. 5.5, 6, higher than 4.5. Then maybe start 7 degrees because this heat released to the surrounding. Then what we do is let's extend this mixing line. So this we call mixing line. Then draw mixing temperature at time point, make the base straight line. There is some point above the line, some point below the line, most point on the line. So extend it to this mixing line. Extend it to this mixing line. Then read the actual temperature of this red colored dot on this temperature axis. So this will be TF. Right. So this point will be the TF. Okay. This red colored dot will be the final temperature TF. Then temperature change, delta T will be TF minus TI. TI from the average of this acid base initial temperature. Since we mix 50 milliliter acid with 51 milliliter base, so total volume of reaction mixture will be 101 milliliter. And the density of this mixture is 1.04 gram per milliliter. And the specific heat of the reaction mixture is 3.89 joule per gram per Celsius degree. So this is a specific heat of the reaction mixture, 3.89 joule per gram per Celsius degree. Not as the lab manual says, it is heat capacity. This is a specific heat. So heat released, this is heat is Q. So it should be M times S times delta T. M is the mass of the reaction mixture. So from volume times density. volume 1 milliliter, density is 1.04 gram per milliliter. So volume, density, you get mass, then times specific heat, then times delta T. Delta T is temperature. Temperature change, we calculated in 1. Okay. So final temperature minus initial temperature. This is the heat. And third is moles of hydrochloric acid. Because hydrochloric acid is a limited reagent. So hydrochloric acid is a 50 milliliter, 2 molar. And sodium hydroxide is a 51 milliliter, 2 molar. So their reaction is a 1-to-1 ratio. So it's clearly hydrochloric acid is a limiting reagent because it's moles less than more of NaOH. So we need to use hydrochloric acid in the calculation. So this mole equals to its molarity times its volume. Volume of HCl times its concentration. Volume is 50 milliliter. 50 milliliter converted to liter. 1 liter is 1,000 milliliter. And its concentration is 2 molar. Clearly, this gives you 0.1 mole. Then the enthalpy change of the neutralization, the delta H of this reaction, acid-base reaction, we call neutralization, will be negative K divided by number of moles of HCl. Because this Q is based on the heat absorbed by water mostly. Water temperature goes up or reaction mixture temperature goes up. So what we calculate the Q is absorbed from the reaction. The reaction is release heat. That's why use negative Q divided by NCl. Q is you calculated here. Then divided by moles of HCl, you get enthalpy change of this reaction. The unit will be used kilojoule per mole. Okay. So this delta H over negative means the reaction release heat. And for the experimental procedure, just watch the lab video shoot. We post on the blackboard at the same place with this PreLab.